Welcome to this video. So today in this video we are going to treat a very important, a very essential and an interesting subject in computing, in computer science and in general. So we are coming to talk about compilers. So in this video we'll be treating about what a compiler actually is. So in talking about compilers, it means that we are dealing with programming languages, we are dealing with code. So in dealing with compilers, we are coming to talk about the architecture of a compiler. We are going to talk about the processes or the computation, the complex activities. That's actually what goes through a compiler, and then what it gives us the output. So, coming to treat how a source code moves into a machine code. Let's say that we have write a program in a high level language. How is that program being understood by the computer? Because what the computer understand is machine code. So before we actually go deeper, I want to explain this very important concept. What the computer understand is the machine code. So when we write a program in a high level language like Python and all those things, what the compiler does is that it actually converts that high level language into the machine code where the machines can actually understand them. Because the early programming languages that were developed like Fortran, and they were actually assembly languages, and then they were a little bit ahead of the zeros and ones. At this point, what we have to understand is that what computers actually understand are zeros and ones. What computers understand are zeros and ones. So without zeros and ones, computers does not understand anything. So in any other programming language that we are using, if you are not using zeros and ones, it means that if you are not using zeros and ones, it means that the computer, whatever language we use, let's say Python, the Python code we have written, the computer doesn't understand. So it is the work of the compilers to actually convert that source code, that high level language, into that machine code where the machine is conversable or favorable with that the machine can actually understand. So let's delve deeper into it. So what is a compiler? That's the first question. So a compiler is actually like a Google Translate, where you write when you write something, or let's say it's like a translator. So let's say when someone is preaching or giving a speech, and then another person is translating, so that person who is translating to the other language. So when someone is speaking in English or preaching in English, and then there are some people who understand French. So what the preacher needs is that he or she needs a translator who is going to translate the English that he's speaking into French, so that the people who are speaking French can also understand. So this is where the translator is the compiler. So to get the message, translate it to the message that the other people can also understand. So a compiler reads your code, the code you write in a high level language like C++, like Java, like Python, and then it actually translates it into machine code or binary code, or actually zeros and ones. That is what your hard disk or your CPU can actually understand and execute. So let's say in a high level language, you write something like we get a pointer. Let's say that you write something like this: int s is equal to 5 plus 3. This is what we are written in a high level language. Then the compiler actually translates it and then optimize it. It reduces redundancy and then some spaces and redundant calculations, and then optimize the code, reduce the code, simplify it, and then the CPU reads it. So that this 1001, let me see. So this 100, this thing over here, this 1001 zeros and ones over here is what actually this is the meaning of it. The meaning of this thing that you have written here, this is what the computer understands it. The computer understands it as zeros and ones. So the work of the compiler is actually simple. What you have written, the computer doesn't understand, so it translate it. That's the compilation process into the machine code where the computer can actually understand it. Alright, so There are 6 stages of the compilation process. There are about 6 stages. So the first stage is the lexical analysis. The first stage of the compilation process is the lexical analysis. So at this place, the computer uses a scanner. Okay. If I want us to go forth and back and then explain it each of them what in detail. So the first one we have is what the lexical analysis. The lexical analysis. So with the lexical analysis, make use of scanner. So when you are reading something or when you come across scanner in the compilation process, scanner is actually what talking about lexical analysis. So this is a token generator. It scans them. It scans the code that we have written, and it generates them as tokens, as simple executable files like spaces, like single digits, like alphabets, and then what it generates them into tokens, and then it what passes them to the syntax analysis or the parser. So the lexical analysis actually reads your code character by character, and then it groups them into tokens, that is words or symbols, and then it strips white spaces and then comments. So if there are any redundant anything, it removes them from it, and then it outputs a stream of tokens. So when you write a program like int x is equal to 5 plus 3, what the lexical analysis, which makes use of the scanner, does is that it what breaks them into tokens. So we have int, we have x, we have equal to, we have 5, we have plus, we have 3, and then we have what a semicolon. So this is what the lexical analysis, that it breaks your code down into tokens, or it generates your code into tokens, and then it passes them to what the parser, which is the syntax analysis. No, so now with the syntax analysis, a quick thing to understand is that it checks the syntax. So it checks the grammar rules of the language. So let's say you are programming in Python or Java. What the code that you have written, it checks it or matches it against the grammar or the rules in that programming what languages. That is what basically that's what the and then the syntax analysis that or the parser does, and then it's able to generate this parser tree, which we'll talk about it at another time. So that, and then it breaks it into some precedence and some mathematical activities or those things, you know, that equal to have a higher precedence than the variable and then the addition sign here and then actually the digit. So the analogy is that, let's say for a sentence, so the lexical analysis or the lexa or the scanner, I want you to take note of that. The lexical analysis is also called scanner. It's actually what splits the sentence into words, and then the parser checks if the sentence is what grammatically what correct. So I want you to take that part of it. Checks it against the rules of grammar, against the rules of that language that you are programming. All right. So the next step is the semantic analysis or the type checking. The semantic analysis. So when you hear of the word semantic, it is talking about what's meaning. So the semantic analysis actually derives meaning from what you have written, from the code that you have provided, or you have written, or you have generated. So it is the semantic analysis in the compilation process that actually will derive meaning. Make sure that what you have written, is it meaningful? For example, when we are assigning a string to an integer, it is the work of the semantic analysis, not the syntax analyzer or the lexical analyzer. No, it is the work of the semantic analysis, which is actually what going to what determine. So the semantic analysis, it checks the meaning, not just the structure. Even as the syntax analysis or the parser is actually checking about the structure of the code that you have written, the semantic analysis actually checks the meaning of the code that you have provided, and it verifies the type compatibility. So are the variables declared being used? So when you use variables without declaring them, it is the work of the semantic analysis that's going to throw that error. That's the type checking. All right, so this is an example. So when you ask, let's say like, oh, this one is good. We are assigning a string s is equal to I. Now let's look at this one. Int y is equal to s plus 5. What we are saying is x int. And why are you providing what an expression? So it's supposed to be 5. So it's what a type mismatch, and it throws the error. I hope you are getting it. So the sky. So for example, let's look at a simple analogy or a simple example that what buttress our understanding even of this subject. So when we see that the sky eats laptops, so oh, the lexical analysis or the scanner will actually generate tokens from this. That the sky eats laptops, but but the sky eats laptop when it goes to the parser or the syntax analyzer. It is actually going to say, there's no grammatical error in this word. But once you get to the semantic analysis, this is what meaningless. How can sky eat laptops? So it's meaningless. So it's what the semantic analysis is what providing what meaning. The next thing is the intermediate code generation. Once there's meaning in this code, there's no error, then the next stage, the fourth stage is what intermediate code generation. So this actually what convert that semantic analysis, semantically meaningful analysis code into what a simplified intermediate abstract code. So that's what it generates an abstract code, a virtual code. All right. So the next thing is what optimization. So what optimization does is that it reduces redundancy and complex calculations, simplifies complex calculations into simplified ones, and then removes so many spaces and all those things and makes the code simplified. So it improves code for speed and efficiency, and then constant coding. So yeah, so that's the work of the optimization, is reduce redundancy even in your codes. All right. So let's say that before we have t1 is equal to 5 plus 3. Let's say before them, from the intermediate code generation, we had what t1 is equal to 5 plus 3. So what is equal to s is equal to t1. So what is going to do is going to compute this and what assign that value to t1, which is in turn is equal to x. So it will assign it and then makes the code very simple. So the last step is actually what the code generation. So this is where the code is actually executed. So that intermediate code, which that optimized intermediate code, is actually what converted into that target specific language that what you are looking. So whether is it in .sz or .iauit or an object file. Alright. So this is just a quick overview of how compilers work. So we have some programs, and then some, whether they are compiled or whether they are interpreted or they are hybrid, which is just in time compiler, which is where Java, C Sharp, and then what to do. We talk about the speed. So some languages which are compiled, we have C, C++, Rust, and then Go. And some interpreted language, we have Python, we have Ruby, and then we have JavaScript. And then we have the hybrid, which is just in time compiler, which is Java, C Sharp, and then Kotlin. So when we check off the speed, you can see that compiled programs are very fast, and the hybrid JIT, just in time compilers, are fast, and then the interpreted language are slower. So when errors are caught, errors are caught before running, but in the interpretation, the errors are actually caught during runtime. And then here, the errors are caught even both before running and during runtime. Errors are both. So Java is a hybrid. So it is actually compiled and then processed and then interpreted. So that's the meaning of what the hybrid is: compiled, the combination of these two. It is actually compiled and then interpreted. Alright, so that's just it, and just a recap: the lexical analysis, syntax analysis, then semantic, the intermediate code generation, the optimization, and actual code generation. So thank you for staying up. Don't forget to share this video around, and then like this video, and then subscribe to this channel. God bless you. Bye bye.